Hey guys, this is Miss McMunn here with geometry. We're going to start with an update on our class in this recording, where you can find things in Google Classroom, what the expectations are, and then after talking about that with the class, there will be some instruction on central angles. So stay tuned. So for our geometry class, we're second block, so we will be having Zoom sessions on Tuesday and Thursday from 10 to 11:30. The Tuesdays will be for instruction for whatever topic we are working on that week. And then Thursdays will be office hours where you can, I'll just be available the entire time and you can join in and just ask me questions when you need to. So you'll have two opportunities for instruction and asking me questions throughout the week in those Zoom sessions. There's a new thing that we're going to start this week. We're going to still do geometry content. We're just going to slow down the pace a little bit. So I want to show you in Google Classroom your work and where to find it and things like that. So when you log into Google Classroom, remember that the stream is very, very confusing. It has a lot of things that I've posted and you have to kind of weed through it to find things. What will help is if you go to the classwork tab. And once you go to the classwork tab, if you look over on the left, I've organized your digital learning assignments in weeks. So if you go to week 1, everything in here is from that first week. And if you are trying to go back and complete things that you haven't done yet, then you'll need to go back to week 1 and go back to that digital learning day 1, that first assignment, and start there, because in math things build on each other, and if you don't do the assignments in the beginning, the assignments at the end are going to be pretty difficult. So make sure you go to Digital Learning Day 1, start there if you have not yet, and then work your way through the days and just do the assignments. If you are working in the textbook for the first 2 weeks, just make sure that you upload photos of your work so that you can get your credit for doing it. Otherwise, I have no idea that you've done it. Week 2 is last week's, same deal, it's all in here. Week 3 is the week that we're in right now. So yesterday was day 11, and all your assignment was to go back to Digital Learning Day 1 and use that vocabulary that you learned to complete this activity. So I've got one person that turned it in, so 8 of you are still working on it. So click on the Google form and make sure that you finish that activity for yesterday. And then today, your only assignment will be to either join in on this Zoom session and respond to my questions during the Zoom, or go back and watch this recording and then respond to my questions on Google Classroom about the instruction. So that's how we're going to be facilitating our class. Every week on Monday, you will have a vocabulary activity like this. And then on Tuesday, that Zoom session will be the instruction for the topic that we are working on that week. And then Wednesday, we will actually have just a practice through quizzes like this on that topic. And you'll have unlimited tries. You'll be able to, take it as many times as you want to practice and to learn from your mistakes. And then on Thursday, you will have the same practice set, but you'll only have one chance on it, and that will be a quiz grade. So you will get a weekly grade, and all the weekly grade is going to be coming from is your participation. So if you are doing the daily assignments, if you took that quiz to show what you've learned, your participation in the assignments is where your grade comes from. Because I know we're in unusual circumstances. We're all learning this new process right now, and I want you to learn the math, but I understand that you are still learning how to learn digitally. So just make sure that you're participating and learning and doing your best. All right, so we've got Monday through Thursday, but then Friday is going to be a catch-up day. So if there's anything that you need to make up or catch up on, that's what you will be able to do on Fridays. I will be in a Zoom session on Thursday for office hours for you to just jump in and ask questions if you're struggling on the practice for Wednesday or the quiz for Thursday. So you can even jump in on the Zoom session on Thursdays and take your quiz while in the Zoom session with me. So that way you can ask questions and I can help you out as much as I can through the quiz. So that is the plan for our class. We're going to keep the same schedule every single week. We're just going to have a new topic every week. So make sure you're checking your Google Classroom and you are completing the assignments because that is where your weekly grade comes from. Okay, so now let's talk about the central angles. So central angles are in circles. And if you think about the word central, it kind of sounds like center, and that's really important to what a central angle is. So I'm going to show you guys something that I found around the house. It's just a frisbee that's a circle. And I'm going to draw on it a little bit to show you what a central angle is. So in a circle, you always have a center point. And this center point is always going to be the same distance away from the outer edge of your circle. So we'll just use the inside of the frisbee for that. And that distance all the way to the edge for every single line like that is called a radius. It's just from the center to the rim of the circle. And actually, all you need for a central angle are two of those radii, so you need two radiuses, and then that center point. And your central angle is that angle that those two radii create. And radii just means two radiuses. It's just the way we say it in math. So if you have two radii, the angle that it creates in the center is called the central angle. So you could draw any two radii. You could even put one here and one here, and the angle that those two make it's called the central angle. So you can make a bunch of different central angles. And what you really need to know about them is that the angle that you create in here, if you were to take a protractor and actually measure that, it will be the same measure of the arc that it creates. So the arc is just kind of part of a circle. It's rounded, it's like this, and it's just a piece of the circle. So this arc right here would be the same measure as your central angle right here. Now, not the length, the measure, the degree measure. So with central angles, anytime you've got your arc, you have your central angle. Anytime you have your angle, you have your arc. So most of the time what you'll see in math is they want you to recognize that relationship and actually see what the angle and the arc would be based off of the information that it gives you. So let me show you an example. Let's see. I need to go to, let's go here, back to the Google Classroom. And what we're going to be seeing is this part right here. So what I was telling you is that if you've got your central angle measure, you also have your arc measure. So this angle in here is 97.81 degrees. So that means that arc DC is also 97.81 degrees. So the blue highlighted is also 97.81 degrees. And I can move my radius around and change the angle, the central angle measure, and that changes the arc measure as well. So no matter what angle you have here, that will also be the angle degree measure for your arc. All right, so I'll show you one more thing. In your parts of a circle, on day one of your digital learning, you should have done a lot of vocabulary and then drawn a circle and put all of these things in there. I just want to review this real quick before we move on into some example problems. First of all, when you have a circle, you always start with a center, like I was drawing earlier. And then the circumference is all the way around that that center, and the center is the same distance away from that circumference every single time. So that is called a radius. So we'll show that one. And it doesn't matter where you move it on the circle, it's going to be the same distance all the way around if you keep the same circle. If you make it smaller, it will change. If you make it larger, it will change. But really, if you have a point anywhere on the circle without changing the width of it or the diameter of it, then it will be the same distance away from the center. And speaking of diameter, a diameter is just two of those radii. So you've got a radius here and you've got a radius here. That purple line is made up of two of the radii. For what we're doing today, we really only need to know the radius, the arc, and some diameters would be nice too. So we'll look at this arc here. An arc is just a part of a circle. It's curved. It's not a straight line. It's not a segment. It is a curved line. It's part of a circle. And that's all you really need to know right now from the parts of the circle for today's instruction. Next week, when we do another part of the circle, we'll talk about some more parts. But let's go ahead and look at some example problems. So this one here says find the measure of angle XTY. And so XTY, be careful about this, XTY is right here. Now, what I'm noticing is that we actually already have kind of a semicircle thing happening here because we've got a diameter right there. And we know that that whole thing is 180 degrees. So if we know that the whole thing is 180, and then we've got these other parts here, we can just subtract those parts from the 180 and get that leftover piece. So this leftover piece here will be whatever 180 minus 66 minus 49 is. And let's do the math on that one and make sure that we are getting it correct. So we've got 180 for the semicircle minus the 66 minus the 49. And we get a 65. That should be the correct answer. Let's see. And it is. Very good. All right. So this one wants the arc JH. So let's look at JH. It's from here to here. All right, I see another semicircle thing happening here. So let's look at this semicircle. Let me change my color so you can see that semicircle. You use the diameter for the semicircle, and then you go all the way around like this. So that means that that whole thing is 180 degrees, just from this diameter and then around this arc. So if that whole thing is 180 degrees, we would take 180 and then subtract the pieces that we already know. So the only piece that is not in the central angle arc that we are trying to find, this green part, is this 50. So we just have to take that 50 away from 180, and that will give us the green part of 130 degrees. And it wants arc JH. So that should be, so if this part was 130 plus this 50 down here, then that will give us the 180 we need for our semicircle. So our answer should be 130. All right. This next one says, what is the measure of arc AB? And so AB is from here to here. And what I'm noticing is that there is a semicircle in there. So the semicircle, remember, it's the diameter is creating it. And then it goes all the way around to the other end of the diameter. So that whole thing is 180. And if we know that this piece right here that is not what we're trying to find is 38, then we just need to take 38 away from 180, and then we will get what's left over, or the purple, the arc AB. So 180 minus 38, let's make sure we put it in our calculator, make sure we get it correct, is 142. So we are going to choose 142. And we got a power up. Very good. Times 2. All right, we're right behind the flash. Now, for this one, it says find the measure of arc GKJ. And this is from here all the way around. So draw on that part that it's asking you to find. And what I noticed is that it is the arc for this diameter, which makes it a semicircle, which means that it's just what we were talking about earlier. It's 360 divided by 2, which is just 180. Just half of the circle. All right, so this is one that we've already done in the video and that we've talked about it. We've had our teachable moment about it. Remember, it's asking for AYB, which is the arc that the 100 degrees is not on. So you would take 360 minus the 100 to get your answer of 260. All right, this one here is asking for the arc WXZ. So you go draw on it. Now, since this is online, you would need to draw this on your paper and kind of show yourself what you're looking at. Or you can kind of use the screen and just go from point to point with your finger to try to figure out what it's asking for. And this arc is actually created with a diameter, which means it's a semicircle. WXZ. Oh, look, I did WZY. So really, if you did it that way, you would have gotten the wrong answer. You need WXZ. So it's got to go all the way around to Z. But it has to go through X since X was in it. So we want all of that. Now, we know what this part is, the semicircle. We know that this all has to be 180 degrees. So I'm going to go ahead and write that in there. We know this part's 180 degrees. So if we take 180 and we add this other part over here, that's the additional part of your arc WXZ, 180 plus 51. Let's put that in our calculators and see what we get. You get 231 degrees. So that should be our answer here. because we used all the information given to us. All right. What is the value of x here? Now, if you notice, x is in the central angle because the vertex of this angle is in the center, right? So this arc that it creates is 80 degrees. Well, central angles and their arcs are the same. That just means x should also equal 80 degrees. All right. So our answer should be right here. Oh, got another power up. What do I got? A streak saver. Nice. Okay, let me make this go away. Not now. Okay. So this is the one that was asking us for arc KJ. So if we go to K and look at J, it's this part right here. And what you've got to realize here is that you've got a lot of pieces, you've got a lot of information. You just got to figure out how to use that information. So we know that this part here is 55 degrees because the central angle is the same. We know that this angle in here is 50 degrees. And what it's looking like is that if this is your diameter and this is your diameter, you actually have two vertical angles right here. So if they're across from each other, remember back with proofs that this vertical angle has to be congruent to this other vertical angle. And that's what it looks like. So that means that the arc will be the same thing as the central angle here, which is 50 degrees. So our answer should be 50. So even if it gives you all like extra information, you just got to figure out what part to use and what's the most helpful. All right, so this one says, what is the measure of angle PTQ? So let's draw on that. We got P, T, and Q. We want this angle right here. Okay, well, we know that the entire circle is 360 degrees. Let me change the color. So if we go around the entire circle, that's 360. And then we've got this piece here, which is 40. So we could take that away. That's not in the purple part that we need. The 60 degrees, we could take that away. It's not in the purple part. It's either, in the 120, it's not in the purple part either. So if we take away the three pieces that's not in the part that we want, then we're left with the part that we want. So you would take 360, subtract 40 from that, subtract 60, subtract 120, and you're left with 140 degrees. So if you're left with 140 degrees, that should be that remaining piece right here, that purple piece. And if the arc is 148 degrees, then that means that the central angle where the vertex is on the center is also 140 degrees. So it should be 140. All right, so this one says arc ABC is 210. What is the measure of angle AOC? This is the one where I do not agree with the image here because it's asking for angle AOC, and that's not very clear. Is it asking for this angle here or this angle here? Which one are you asking for? So what we found out is that it's actually asking for the top angle, so you have to take 210 away from 360, which will give you 150. So right now the answer choice is 150. You can also click on 210. I put that both of them are correct, and I'm going to work on making that image more clear so that you know which angle I'm talking about. All right, and that is the entire practice set. You just need to complete this practice set on Wednesday, And then on Thursday, you'll have one opportunity on this set to show me what you know. So Wednesday, you'll have unlimited tries, and Thursday, you'll have one chance. And really, all this is doing is helping you remember this relationship for central angles, that the angle and the arc are the same. Only if the vertex is at the center for your angle, which is then called a central angle. All right, so you're just going to practice the central angle, and then that will be it for this week. And next week, we'll move on to the next topic. I hope that you and your family are doing well. I hope that you are making wise choices. Use your time wisely. I hope you have a wonderful day, and it was great to see some of you guys in the Zoom session, even though some of you couldn't stay. I'll see you guys on Thursday.